Okay, this is lab report 4, oscillations. Okay, so for the purpose of this lab, so it's analyzing the oscillating motion of a spring mass system that moves in two dimensions, so x and y, and basically how do the various energies change throughout the system, and also is total energy conserved throughout the observed motion. And for a period of this lab, so the model from the code doesn't directly match the experimental data, but fundamental principles still apply. But for the fundamental principles of this lab, so the main principle is energy principle. So delta E is equal to zero. And we're looking at gravitational potential energy, spring potential energy, and also the kinetic energy for the mass and spring. As for the other principles, so F net equals ma, which is primarily for the spring force and gravity, as well as the momentum principle, which is used to determine velocity to update the kinetic energy. And so the initial conditions and assumptions. So the mass is equal to 0.402 kilograms, and then the equilibrium length of the mass and spring is zero point 0.7 meters. And so also the system is the mass spring of the Earth, while the surroundings are the rest of the universe. It's assumed that the spring is massless, and the only forces involved after the mass is swung are gravity and spring. That with after calculating the spring constant, since at equilibrium, the force of the spring is equal to mg. This equation was used to find L naught, which is the relaxed length of the spring. And so this is X and this is Y. They both follow a sinusoidal path, which correlates with how it should be because the system is an oscillating motion. So these are the constants that were used for the lab. So the spring constant was calculated, and also this L naught was calculated. And then as for the vector L, which is for the spring force, so L is just equal to the ball position minus the spring position, and then this is just to find a unit vector of L, and then this is S. And then these are to compute all the energies, and then this is for total energy. And then over here is just the initial energy, which is just from this value, from these values. And then the force of gravity is just equal to negative mg in the y direction only. And then F spring is just the negative, and then time spring constant times the displacement, and then times the unit vector of L. And continue. So F net is just equal to F spring plus F grav. Then as for the velocity, so velocity, this is just updated. So yeah, obviously this is just F net divided by the mass times delta T, which is just derived from momentum principle. And then for the position just changes with velocity as a function of time. And then update the spring. So this is for L. So then this is just for ball position minus spring position once again. And then using that new value, you find the new L hat and the new S, which is just the displacement. And then for the energy changes, so this is K, this is the new K, and then you find delta K, and this is new UG, etc. And then for delta E, it would just be this new E minus the initial energy from before video, and then the model, this is from the code. As you can see, the amplitude of the model is greater than the experiment, and also the frequency is slightly different. It seems that the experiment has a slightly higher frequency. And so as for the total energy, so energy of the system overall was zero, which means that the delta K, delta U grav, and then the spring potential energies, they all added together equals zero at each point within the model and the experiment, which correlates with like the fundamental principle. And then as for the oscillation period, so from the X data, is about 1.6 seconds, while the Y data is about 1.5 seconds. And an observation made was that in the X direction, the number of frames for a full period of oscillation was between 16 and 18 frames, while in the Y direction, it was always 16 frames. And this is probably because the oscillation period of X was solely based on the initial force applied by the person in the video. But for the oscillation period of Y, it's still affected by the force of gravity during the motion. And so to conclude, so this, from before, the discrepancy between the model and experimental data shows that the motion of real springs don't directly align with ideal springs. And also this could be due to the fact that the tracker values could be slightly off. due to the placement of data points not exactly aligning with the center of mass. The other point, the experiment supports the fundamental principle of energy being conserved with the system, because back from that graph, delta E was roughly equal to 0, and this is because there was no external work since the Earth was also part of the system alongside the mass and spring. Thank you for watching.